This question belongs to Digital Logic Design System and was asked in GATE 1990, and the topic name is Circuit Outputs. So the question states, choose the correct alternatives, more than one may be correct. Two NAND gates having open collector outputs are tied together as shown in the below figure. So in this figure, two NAND gates are outputs are tied together using an open collector. Then the logic function y is implemented by the circuit is y equals to abc plus de, y equals to abc plus de whole complement, y equals to abc into de, y equals to abc into de whole complement, and y both c and d. So let us see the meaning of this. Two NAND gates having open collector outputs are tied together. So there may be two cases. Whenever we are tying the outputs of open collector together, whenever open collector is tied together, then two cases can occur. Then the common line can behave like either a wired AND gate or it can behave like a wired OR gate. So which means either this gate will behave like a wired AND gate or it will behave like a wired OR gate. Now we have some other logic for the wired AND gate. So if the gates being used are NAND gates, which means if we are using here NAND gates, if NAND gates are being used and the outputs are tied together, then it will create a wired AND configuration. And if the NOR gates are being used over here instead of NAND gates and the outputs are tied together, then it will behave like a wired OR. The reason for the first one behaving like a wired AND gate is because the output of NAND gate is low. The output of NAND gate is low whenever all the inputs are high. And and this overall circuit will output a low signal whenever all the AND gates will output low signal. Because what is the truth table for NAND? Let us see for two inputs. So A and B whole complement NAND. So 0 0 0 1 1 0 1 1. For 0 0 it's 0 0 1 it's 0 complement, which means it's 1 into B whole complement. It's 1, it's 1, it's 1 and it's 0. So we can easily see that the output of NAND gate is low whenever all the inputs are high. So when all the inputs are high, the output will be low. And this output will be low when all the inputs will be high. And this output, as it is behaving like a wired AND, it will be low if all these will give a low signal, then this output will be low. Thus NAND gate behaves like wired AND if we are using NAND gate. And if we are using a NOR gate, then it will behave like a wired OR. Why? Let me give you the first the truth table for the wired OR. So the wired OR truth tables look like this. Here 0 0 it's 1, it's 0, it's 0, it's 0. So it will, because the output of NOR gate is low if either of its inputs are high. If either of the input is high, then the output will be low. And so the overall circuit will output a low signal if both the NOR gate outputs are low. So which means in this circuit we are having a wired AND over here. So here this can be replaced by an AND gate. Using an AND gate can be used to replace this one. Let me draw it more precisely. So here we can have the configuration like this. So here we will get an AND gate. So let us see what will be the output. So here we are using a NAND gate, which means we will get A into B into C whole complement, and then we are doing AND with this one D into E whole complement. So now, how will we evaluate it further? We will apply the De Morgan's law. So A into B whole complement. It can be written as Y equals to A into B into C. What is De Morgan's law? It says A into B whole complement is equals to A complement plus B complement, and A plus B whole complement equals to A complement into B complement. So using this law, A complement into B complement can be written as A plus B whole complement, which means ABC plus DE whole complement. So the answer is option B.